let's jump straight in. Oh, God, right. So our first example, we've got a fraction here. Now remember, we're doing equations, we're solving equations. And we've got a fraction here of 3 times x plus 2 over 5 is equal to 3. Okay, so we're going to run through this one to start with, and then we'll let you go and try one by yourself. So remember, when we have a fraction, we don't actually like fractions. Fractions, we try to avoid at all costs if we can. So what I want to first try and do is get rid of that fraction. Now, what's really important in equations is that we are using inverse or opposite operations. Okay, so whatever it originally was, we want to do the opposite of that. So if it was plus, we now want to minus. If it was minus, I now want to plus or add. If it was times, I now want to divide. And if it was divide, I now want to times. So those inverse operations are super, super important. So the first inverse operation I'm going to start with is dealing with this denominator. Now, because it's a fraction, it is telling me that I'm taking the numerator being divided by the denominator. So I was doing division, that was my original, which means that I now need to do the inverse and multiply. So the first thing I'm going to do is I'm going to multiply by 5. That gets rid of that denominator. And then what happens is I need to remember that in an equation, I need to keep both sides balanced. So I also need to times the 3 on the right by 5. If I don't do that, my whole equation goes out of whack, and then I'm not actually solving for the correct thing. So we need to remember to keep it balanced. That then leaves me with 3 times x plus 2 is equal to 15. Okay, so I've dealt with a fraction. That's gone. That's great. Don't like a fraction. I now don't have to worry about it. The next thing that I see is that I have a 3 times the bracket. So I have distribution here. So I'm going to distribute this 3 into my bracket. Now, if you had done the distribution first and then dealt with the fraction, absolutely fine. Not a problem at all. All right. So I am going to do my distribution second. If you do it first, that's cool. No stress. So 3 times x is 3x, and 3 times positive 2 is a positive 6. So now I've got 3x plus 6 equals 15. Now this is a much nicer equation. I know how to deal with these, hopefully. I feel a bit more confident with this. So the first thing I'm going to do is say, okay, well, I know that my x is currently sitting attached to my 3. So it's 3 times x. So let's get rid of that plus 6 first. That's easy enough to do. If I was originally adding, I am now subtracting. I'm using the inverse. So I want to subtract 6 on both sides. Okay. If you want to write your next step down as 3x plus 6 minus 6 equals 15 minus 6, you are more than welcome to do so. But if you are happy to jump straight to 3x is equal to 15 minus 6, which is 9, then you also must feel absolutely comfortable and confident to do that. Alrighty. Now, we know that that x is still attached to the 3. And quick sticks, if someone wants to raise a hand or someone wants to pop it in the chat, what operation is happening between the 3 and the x? Feel free to raise a hand if you want. Otherwise, you can pop it in the chat. What operation? Come on, guys. I know you know this. Awesome. Good. Yes, I'm seeing all the multiplications now coming through. Good. Well done. Multiplication. So if my original operation was multiplication, I now want to do the opposite. So I want to divide. So I'm going to divide both sides by 3. And remember, it must be both sides. Otherwise, my equation is going to go out of whack. So now I've got the 3 divided by 3, which essentially cancels. So I've got just my x on the left is equal to 9 divided by 3, which is 3. So in this case, x is equal to 3. So I'm just going to do that just in case you want to take a screenshot. X is equal to 3. Okay, how do we feel after that one? Thumbs up, thumbs down. Cool. Nice, guys. Good. Well done.
My people, well done.
Awesome. Excellent. Right. So let us have a look then at question 2. So question 2, no fractions, but I do have some distribution. Okay. So I'm going to ask you to try. No, let me start off this a little bit. Right. If I have a look at question 2, just because I don't want you to get confused right from the start. So if we look at question 2, we've got 5 minus 2 times x plus 5 is equal to 3 minus 3x times x minus 1. Now, what's quite important here is that we realize we have terms on either side of our equation. So this 5 is one term. This whole negative 2 times the bracket is a second term. Over on the right, this 3 is a term, and this negative 3 times the bracket is a second term. Now, it's really important that we see those terms, because when I'm going to now start simplifying, if you think back to bodmas, the first thing that I need to do is I need to deal with the multiplication, not the additional subtraction, the multiplication. So to start this, what I actually want to do is I want to take the negative 2 and I want to multiply that into my bracket, because that's the operation I want to start with. And on the right, I want to take the negative 3 and multiply that into my bracket, because that's the operation I want to start with. So it's really important that we remember that there are separate terms and that we want to do the distribution or the multiplication first. So if I do that, I've got 5. Now I do the multiplication. So negative 2 times x is negative 2x. Negative 2 times positive 5, be careful of your signs. A negative times a positive is a negative. So negative 10 is equal to, the 3 stays there because that's a separate term. I'm going to deal with that multiplication first. So negative 3 times x is negative 3x. Negative 3 times negative 1, and negative times a negative is a positive. So positive 3. All right, so I'd like you to try and finish off this equation for me and try and tell me what x is going to be. So remember, try and get all your x's together, try and get all your constants or your numbers together. So x is on the left, constants on the right, and try and solve for x. So get x alone. And then if you're feeling brave, please raise your hand and explain to us how you got your answer. Or if you're not feeling so brave, I'd love to see in the chats what you got. All right, guys, you're doing really well. You got this.
Let's do this, my people. Let's do it. Anyone who wants to finish? Anyone feeling brave? Priscilla, I see you. See you, my people. I see you. Tabella, I also see you. Ilse. Wanna try something?
And even if you don't want to give
it a
the
try
whole
and answer.
Yeah, even if you don't want to give the whole answer, even if you just want to tell me what the next step should be, that would be great. You don't have to do the whole thing, even just the next step. You're welcome to share with us. We'll give you a second or two to try and finish it off. All right, and remember, any questions that you have, pop it in the chat. Pop your answers in the chat as you go. Doing really well, guys. And good, exactly. Constants on one side, variables on the other side. That's what we want to try and do. It's going to make your life a lot easier if you do that. And remember those signs, we just need to be mindful of what sign is what, and so that we do our inverse operations correctly. Okay, guys, does anyone want to try for us? Be brave. Even if you just start me off, you can tell me what the first step would be. No one. Okay.
You guys don't want to give it a try? Oh, you sure you don't want to shine?
Are we
It's your
warming
time
up?
to shine. Priscilla, I see you. I see what you're doing. I see you.
Okay, we're warming up. You're gonna answer the next one. I know it. All right, guys. So if we have a look, so there's a couple different things you can do from this point. What I'm actually going to do is I actually see firstly is that I've got some like terms. All right. So on the left, the 5 and the negative 10 are like terms, leaving me the negative 2x. And then on the right, the positive 3 and the plus 3 are also like terms. Okay. So in order to make my life a little bit easier, I'm just going to add those like terms. It just means that I've got less terms that I have to work with. So on the left, I've got the minus 2x, and then 5 minus 10 is a negative 5. And then on the right, I've got the minus 3x, and then 3 plus 3 is 6. So it's just a little bit more manageable for me to work with. Now, when I've got x's on both sides of my equation, what I want to do, as was said, is get the x's to the left. Now, I'm saying to the left because generally what happens is we write our answer as x equals some value. So the x is generally on the left in our answer anyways. If you put the x's on the right, it's fine. As long as you get x alone, your answer will be perfect. So I want to get my x's to the left. What that means is that this negative 3x needs to come over the equal sign. And the only way for me to do that is to use inverse operations. So I now need to subtract, I need to add 3x on both sides. Okay, so what that results in is a negative 2x plus 3x minus 5 is equal to 6. So now I've got both x's on the left. But now what I want to do is I want to get my constants, so the numbers that are alone, to the right-hand side. Because if my x is on the left, I want everything else to be on the right. So that now means that this negative 5 needs to move. And the only way for me to do that is to do my inverse operations, so to plus 5 on both sides. That is going to result in a minus 2x plus 3x is equal to 6 plus 5. All right. Now from this point, I've got like terms on either side, so I can just add my like terms. Minus 2x plus 3x is then just a positive x, and 6 plus 5 is 11. And so I get that x is equal to 11. All right. So I hope you got that. If you didn't get that, please make your corrections or ask me a question if you're a little bit confused. This was a little bit of a tricky one because we had to remember that distribution and we needed to make sure that we were distributing the correct value into the brackets. So just bear in mind that sort of stuff. Okay, and then remember those inverse operations as we go. Can I get a thumbs up, thumbs down, how we feel after that? And if you aren't understanding, you either need to put your question in the chat or you need to raise your hand so that I can help you. Thumbs up, thumbs down, how are we going? Okay. Right, I see one or two.
Yes, it's sort of half.
Right, if there is a thumbs down and you have a question, please either ask it. You can also direct message Yolanda and she can help you as we go along. Or if you think it's a little bit more practice, we're going to do more. Okay. And it's really important that you ask, guys. That's the only way we can help you. Okay, Chelsea, I see your thumbs down. Do you have a question you want to ask, or do you have somewhere specific that you're confused and I can maybe try and explain, or do you just need a little bit more practice? And you can raise your hand if you want to answer. Okay, I'm going to assume it's more practice, which we're going to do. So don't stress. Otherwise, like I said, just pop your message. Right, how we got to the second step. The second step, guys, remember what I started with. Let me just do it like this. what I started with was my distribution. So what I'm starting with is by, everything's going wrong. I'm sorry. I'm gonna start my
No,
sentence.
that's okay. I'm also having issues, guys. I'm having load shedding. So you can't even see my face at this moment because South Africa, hey. Yep.
All right. So those of you with the thumbs down or saying I'm confused, I'm explaining it again, so please listen. In my equation, I have got separate terms on either side. And so what that means is that this -2 on the left needs to be multiplied to the x and to the 5. And this -3 on the right needs to be multiplied to the x and the -1 before I start doing any inverse operations. So in my second step, this -2x came from me saying -2 times x. The -10 came from me saying -2 times +5. So it's from the distribution. Over on the right-hand side, the -3x came from me saying -3 times x. And the +3 came from me saying a -3 times a -1. And we know that when we times a negative and a negative, we get a positive. So that was just my distribution step, that second step. I then saw I had like terms. So that -10 and the +5 are like terms. And 5 minus 10 gives me a -5. So I'm just simplifying up either side. The same thing can happen on the right. On the right-hand side, I see that I've got a +3, and 3 plus 3 we know is 6. So I've just neatened up either side. It makes it easier to work with. If you don't do that, it's absolutely fine. You will get the same answer. And then from that point, I started using my inverse operation. So I got my x terms to the left. I got my constants to the right using my inverse operations, and I solved for x. Okay, cool. Well done, guys. And again, any questions, you just need to pop it in the chat. Excuse me. So let's have a look at question 3. I say pop it in the chat or raise your hand if you have a question. So question 3, we've got 2 times 3x plus 2 minus 5 is equal to minus times x minus 1 plus 5. Now, what's really important with something like this is that if we've just got a minus sign sitting in front of a bracket, we actually have a ghost 1 in front of that bracket. And so what that means is if I now want to distribute, which I definitely do, what I'm multiplying into this bracket is a -1. So I'm saying -1 times x and -1 times 1. Over on the left, this is a little bit easier. It's a 2, so it's 2 times 3x and 2 times 2. So this is quite similar to the one we just did. So I want you to try it. Take a second or two, give it a try. Start with your distribution, and then you're going to start to get all your x's on the left, all your constants on the right, and solve for your x. Right, and you can put your answers in the chat if you want to, and you're feeling a little bit more confident, you can raise your hand and you can tell me how you did it. If you don't want to do the whole thing, you can just tell me what the next step should be or where you should go from there, but give it a try, okay? Right, and like I say, if you're confused, start with the distribution. That's where you're going to start. From there, you're going to then put all your x's on the left and all your constants on the right, and then you can solve for x. So that's where you need to start. If you're a little bit confused, I've now told you where to start with this equation. Okay, you got it. You're doing well.
You're doing good, my people. Those of you that are totally confused, remember that we're continuing with this work. So basically what I mean is that you can go to the previous work that we've already done on equations, and you're going to start watching so that you can understand. Okay, just need more and more practice, guys, but you guys are doing well. Well done.
So just guys, based off that, what I'm going to do now is in the chat, I've just posted a link, and if you follow that link, you can get to the videos. All right, it is, you have can potentially get access to other grades. So let's say, for example, you're really struggling with equations, you can always go back to the grade 7 equations, do some revision there, and then go back and watch the grade 8 videos. But the link's there for you. So please, by all means, as Yolanda said, just go and have a look at those videos that have already happened. Okay, and then do the practice as you go. Does anyone want to try and tell me what I should do?
Let's go, my people. Anyone wants to raise their hand? Why is this not talking to us today? Hey, my people, you need to talk to us. Kaden, want to give it a try? Amanda.
If you don't want to try the whole thing, can I ask, can someone just give me the answer for this distribution? Just that one. If you can just tell me that, then I would appreciate it. So what is 2 times 3x plus 2?
Lisedi has given the whole answer. I'm not sure if it's correct or not, Lisedi, but would you like to raise your hand so you can tell us how you got your answer?
Okay.
Theo, we see you on the chat. Well done. We see you. Okay, Scarlett. Yes. Someone to the rescue. Hi, Scarlett.
Hello, ma'am.
Hi, Scarlett.
Hello.
Hi. So for that one, I said 6x plus 4.
Good. Do you want to carry on with the solution, or you just want to give me that?
I just actually wanted to give you that.
Okay, can you hang on 2 seconds? Can you tell me, Scarlett, what this multiplication is? So what the answer to that distribution is?
Okay, just hang on, please.
If you don't want to, you can say no. It's absolutely fine. I'm putting you on the spot.
You did well already, Scarlett. Well done. I'm proud of you.
I'm trying to figure that part out, ma'am.
Okay,
Sorry.
no problem.
That's
No problem.
okay.
Take your time. Lisady, do you maybe want to try? I can see your hands up.
Hey, Lisedi, we are on you.
Hi, ma'am.
Hi.
So, ma'am, what I did there, I said x plus 1.
Okay, so just quickly, this was a positive x and we're timesing it by a negative 1. So a negative times a positive should give me a negative x. But I definitely agree with that plus 1. Well done.
Yes, then I said plus 5. Then I said, therefore, 6x plus 1, because I subtracted 4 minus 5.
Okay, now what is 4 minus 5? Is it plus 1 or minus 1?
Minus.
Minus 1. Good. And on the other
Well
side?
done.
I said x plus 6.
Good. So remember, it's a minus x, and then I agree, plus 6.
6, yes.
Okay. Do you want to carry this on using the answers I've got here, or would you like to try it or give someone else a chance, or are you happy to carry on?
Try to carry on.
Okay, good. Well done. I like that. Let's go.
Done. Proud of you.
So 6x minus 1, it's 5x.
This minus 1?
Okay. This, you're gonna take it to the other side.
Well
So
done.
Yes, so it's gonna be 6x minus x. It's gonna be plus.
Good. Well done.
Done. We're getting there.
Excellent. Okay, keep going. You got it.
Equals to 1 plus 1 minus 6.
Okay, so this plus 6 stays on the right, so it's just 1 plus 6. The plus 6
Okay.
doesn't change because it's staying there.
Yes.
Okay, cool. Keep going. You've got this. You're doing so well.
So it's gonna be 6x.
What's
Oh,
6x
no.
plus x?
Is it 7x? Because there's
Awesome.
Yes. Woo.
Good. Equals?
plus 7.
Good.
Well
And
done.
now what do I do?
We divide, I think.
Good. What am I dividing by?
Oh, that part by 7.
Good.
No.
Oh, the city's on fire tonight, yeah.
Well done. You did it. Look at all of that. It's all
So
you.
Sadie, what is x equal to?
To 7 or 1.
1. Because what's 7
1.
divided by 7? 1.
1.
Oh, you are amazing. Well done. That was such
Thank
a
you.
tricky question. You did that so nicely. Well done. And you corrected everything.
Well done.
Absolute
Yes.
champion. Okay, guys. So hopefully you got that. Take a screenshot if you need to make corrections or anything. And like I say, if you have questions, please just pop your hand up. Oh, golly, Miss Molly. Right, let's try one more before we take a brain break. Sorry, my whole screen just went black. Oh, she's been mean. Hang on, let me see if this one's nicer. Right, I know I've skipped numbers, but it's okay. We're going to do question 5. So question 5 is minus. Now again, when we just see that minus just chilling in front of a bracket, we need to remember there's a ghost 1. So when I distribute, I'm actually multiplying a -1 into the bracket. So I've got minus 4x plus 2 minus 2 is equal to 4 minus 2x times 3x minus 5. And remember, on the right, this 4 and this minus 2 times the bracket, they're separate terms. So when I distribute, I'm actually multiplying in the -2. I don't do subtraction first. I do multiplication first. Okay, so give it a try. Again, if you have questions, pop them in the chats. And if you're feeling brave, like Lesedi, I'd really like to hear how you did your answer. But take a second or two, have a look. Start with your distribution. So if you're feeling a little stuck, start with the distribution, and then you can start getting your x's to the right side and your constants to, so x is on the left, constants to the right, and you can start solving for x. But you guys are doing really nicely. Well done. Sorry. Sorry about that. Had a bit of a frog in the throat. You guys are doing well. And if you're not feeling brave to do the whole answer, if you just want to give me like the first step, so sort of like what Scarlett started off for us, just telling me like what the first distribution would be, that would be awesome. Doing well, guys. Right, does anyone want to start me off by just telling me what this distribution would be? So the one I've circled in green. Does anyone want to try just that little bit for me? You can raise your hand if you would like to.
I can already see some of your answers on the charts. Guys, you can talk to us. We don't bite. Let's go. Let's go. Raise your hand. Let's go, my pibs.
Okay, guys, so let's have a look. If we've got a -1 times 4x, we end up with -4x. So weird looking negative 4x. And then we've got -1 times +2, which is a -2. Then I've still got this -2 on the end there. I can deal with that in a second. I'm sorry, that's just going to upset me how ugly I've written all of that. So I'm going to try again. Okay, so we still have the -2 there. I'll deal with it in a second, but let me first deal with the other distribution. So that 4 is going to stay there because it's a separate term, not dealing with it just yet. But I am going to multiply in my negative 2. So I've got negative 2 times 3x, which is a negative 6x. And then I've got negative 2 times negative 5. Now I need to be careful. When I times a negative and a negative, I get a positive. So this is plus 10. Right now, again, if you don't want to, you don't have to. I'm just going to neaten up either sides by adding together the like terms that I have on the left and on the right. So on the left-hand side, I've got my minus 4x, but then I've got a minus 2, which is a negative 4, is equal to, got my minus 6x, but then I've got a 4 plus 10, which is 14. All this does is it just helps me decrease the number of terms that I'm working with. And so it just makes my life a little bit easier. If you don't do it, like I say, it's not the end of the world. Okay, now what I want to do is I want to get all the x's over onto the left-hand side. So does someone maybe want to raise a hand and explain how we would get this negative 6x over to the left? Someone want to try? Just how I would deal with that negative 6x. Kendra,
Let's go, my people.
you want to try?
You can put your answer in the chat since we know that, oh, well.
Yeah, answers in the chat. Faith, you want to try? Anyone?
I'm just so focused in writing.
Oh, guys. Okay, I
Hello,
know
my
you've got
people.
this. You got to have some faith in yourselves. You know what's
My
going
network
on.
is so bad on my side.
Right, what we do is, awesome, Faith, thank you. So what we do is we move it over by doing the inverse operation. So well done, Faith, Christelle. We add 6x on both sides. So what that is going to do is it is going to end up with minus 4x plus 6x minus 4 is equal to 14. Okay, so guys, tell me now, how am I going to get this negative 4 over to the right? What do I do? How am I going to get it there? You can raise a hand. If you want to put it in the chat rather, that's absolutely fine. How do I get that negative 4 over to the right-hand side? Good, awesome. Chriselle, thank you. So
Well
we
done.
add 4. We do the inverse, the opposite operation. Right, I know you guys, some of you are struggling with the network because, you know, load shedding, it's not great. So don't worry, I completely understand. So now we've got minus 4x plus 6 is equal to 14 plus 4. And now we've got like terms. So minus 4x plus 6x is 2x and 14 plus 4 is 18. Now all we need to do is get that x alone, and to do that we know we divide both sides by 2, and 18 divided by 2 is 9. So, oh no, so sorry everyone. And so x is equal to positive 9. Okay, so I saw one or two answers come through of x equals negative 9. Well done. Oh, negative 9, sorry guys. X equals positive 9. Well done, that's really good. I'm just going to do that in case you want to take a screenshot. So what's really important is that when you see distribution, you start with the distribution. Then you can start putting your terms on the correct side of the equal sign. Okay. Can I get a little thumbs up, thumbs down? How are we feeling about these questions that we've done so far? Good.
Well done, people. Well done, my peps. Guys did well. No, Bute, is that a question?
Yes, ma'am, it's a question.
Yes.
Ma'am, we just quickly want to ask something. They're at minus 4x plus 6x. It's positive 2x. So
Yes.
I think we got yeah, we got it wrong. We thought minus 4x plus 6x is minus 2x.
Okay, so the way I like to think about these sometimes is on a number line. So if, sorry, let me just draw my number line. It takes forever. So if I'm already sitting at a negative 4x, if I'm now adding 6 to it, what I'm doing is I'm heading towards the positive numbers. So I'm at negative 4 and I want to add 6 onto it. So I'm going to the right. 1, 2, 3, 4, 5, 6. So that now takes me to a positive 2 because I'm adding on more than the negative value.
Okay.
Cool.
All right, then it makes sense. Thank you.
Yeah, so sometimes a number line is quite useful when we are adding and subtracting with negatives. Awesome, guys. So let's take a little break here. Because sure, you're doing well. You got this. So our brain break. Oh, Kendra is going to lead us in a stretch. Follow Kendra. It's on it. If you oh, he's got the shoulders going. Yeah, there we go. Yeah. Right. If you want to do the brain break, it's a little bit different today. I just thought let's shake it up a little bit. So brain break is basically just taking a break from the maths that we're doing and just giving your brain a chance to think about something else. So the brain break is what, and I didn't know that these were called this, is what we call a dingbat. And basically it's when you get a picture that's saying a phrase. So for example, in the first picture, we've got stand on top of the letter I. And so its phrase is, whoops, I understand. I is understand, so I understand. These are not for everyone. This is not my strong suit. So have a try if you can. And let's see what we come up with. Okay, I'm seeing some good ones coming through. Doing well.
I'm loving this joke. Why shouldn't you let advanced maths intimidate you? It's really as easy as pie, guys. We should not let mathematics intimidate you.
You got it. And remember, guys, if you don't get the brain breaks, that's absolutely fine. It's just something to sort of give your brain a little bit of a break from the maths. I'm glad you guys enjoy my jokes because I feel like the other class doesn't. And I appreciate that you appreciate them. It makes me feel a lot better about them. Okay, let's see. So I definitely agree. Number 2, big bad wolf, because the bad is big. So big bad wolf. I'm a little bit embarrassed about this, but I can't actually remember what 3 was. You've said your mind, and I think it was something like you out of mind or you out of your mind because the you is missing. But that's on me because I forgot that one. 4 is 2 steps forward, 1 step back, because the first 2, the steps are spelled correctly forward, but the last one, step, is spelled backwards. So 2 steps forward, 1 step back. And then
that's so cool.
I'm terrible at these. I'm so bad. And then I have to Google the answers, otherwise I'm just
Yes, that's what I'm
Annalisa, thank you. You are out of your mind. And then the last one is double vision. Exactly, because it's vision twice. So there's double vision.
Well done, guys.
Nice. Okay. Now, guys, if like the equations with the distribution and the fractions, you still need a bit more practice, please make sure you do come back to the next lesson, because we are going to sort of consolidate and just revise everything that we've done. But sort of what today we need to chat about is how we deal with equations and exponents. Okay, because this is still something that we can deal with. And like, if you plan on doing maths further into like grade 10, grade 11, grade 12, so if you choose to do maths as your mathematical subject, then this concept and this ability to work with exponents is actually really, really important. Okay, so it's good to get practice. Okay, Micah, don't even stress about the brain break. Trust me, I think I spent about an hour trying to figure these out. So you're not alone. Don't worry. Okay, so let's have a look at the first one. So we've got x squared equals 49. Now, the first thing is that we understand what squared means. Anytime I see squared, so x squared, it is saying to me that I'm multiplying exactly the same value twice. So if we're saying something squared equals 49, the question I need to ask myself is, what same number do I times twice to get 49? So I'm seeing some lovely answers here in the chat. If you are really comfortable with your perfect square numbers, you'll know what the answer is pretty much straight away. But the way we do this in like following our equation steps is we need to use those inverse operations. But now we've got slightly new operations that we're working with. So when we've got a value squared, the inverse of that is to square root it. If on like the flip side, if I'm square rooting a value, the inverse is then to square that value. So square and square rooting go hand in hand. Okay, so I'm seeing some lovely answers, and these are all really great. There's just something I want to chat about with the answer. So I think for the most part, we can all agree that 7 is where we're heading. If I'm going to use those inverse operations, what I want to do is I've got a squared, so I actually want to square root, because as I've said, the inverse of squaring something is to square root, and what happens is those operations actually cancel. And I want to do the same thing on the other side because it's an equation. I want to keep it balanced. But what's really important is that when we square root something, we actually get a plus or a minus answer. And I'm going to explain what I mean now by that. So the answer here is x is equal to plus or minus 7. Okay, so we all got 7 and we're all happy with that. But why is it plus or minus 7? Well, let's think about this. If I've got positive 7 squared, I've got 7 times 7. So a positive times a positive, so we get positive 49. That's great. We're all happy with that. However, we can also have negative 7 squared, because when I've got negative 7 multiplied by another negative 7, I know that when I have a negative times a negative, I get a positive. And so this actually also gives me 49. And so both positive and negative 7 give me 49. And so that's just something to be mindful of, that when you square root something, you can get a positive or a negative value. So 7 is absolutely fine, but it's also really important to remember that it could also be negative 7. So that's when we square root. So I'm just going to make a little note here for us. I don't know what's happening. In that, let's put it down here. When we square root, we can get a positive or a negative answer. Okay, now that concept of getting a positive or negative is going to be so useful to you as you start to move on in maths. So in grade 9, this comes up. This is going to come up in grade 10, grade 11, grade 12. So just understanding that bit is really, really important. Okay, so can I just get a thumbs up if everyone's happy why it's a plus and a minus, and we're happy that we've got plus or minus 7?
Yes, well done, my people. We
Awesome,
get this.
guys. Yeah, and that's amazing, because sometimes this is so hard to get, but it's really, really good. Well done you that you're getting this. Right. So let's have a look at another example. So this is going to be quite similar, but what we now have is a coefficient as well. So remember, the coefficient is the number right in front of the x. Now, much like any other equation, if I had given you the equation 2x is equal to 32, your first step would be to divide both sides by 2. So just because I've got a square there doesn't change that. I want to try and firstly get rid of that coefficient. So I'm going to divide both sides by 2 in order to get the x squared alone. Only once the x squared is alone will I then do the square rooting. So does someone want to maybe tell me on the chat, or if you're ready, feeling brave, raise your hand. What is 32 divided by 2? I'm glad we're all brave on the chat. That's great. Well done. Right.
Yeah, my people are feeling brave on the chat. And
Good.
they don't want to turn
Excellent.
to
Right.
Still love you guys.
You'll eventually get there. You'll be talking out years off. It's fine. Right. 32 divided by 2 is exactly that, 16. Okay. So now this is a little bit easier to deal with because we have to ask ourselves a very similar question as what we did in the first question. What two identical numbers do I multiply together to get 16? Now, we need to remember to show this. We're doing a square root in order to get rid of that square. And we also need to remember, as I've said, when we square root, we can get a plus or a minus. So can someone tell me what the square root of 16 is? You can raise your hand. If you're not feeling that brave, you can pop it in the chat. What is the square root of 16? Awesome, guys. Cool. Great. It is 4. But remember, we square rooted, so it must be a plus or a minus 4. For the same reason as I said earlier, positive 4 times positive 4 is 16. Negative 4 times negative 4 is also positive 16. So it can be either one of those. Right. Well done. You're getting this. Well done, guys. Okay, so let's have a, oh gosh, there's so much. Let's have a look and see what happens when we've got cubes. Squares and cubes are really the exponents we work with most often. And a cube is just slightly different in that I'm now thinking about what 3 identical numbers do I multiply together to get my answer. So in this case, I'm asking myself, what 3 identical values do I multiply together to get -1? Okay, so again, just bear in mind that if we are cubing something, the inverse is to then cube root, and a cube root we write with a little 3 in front of it. And if we are cube rooting something, the inverse is to then cube it, right? And I'm seeing some lovely answers on the chat there. In response to my question of what 3 identical numbers do I multiply together to get -1, you are all 100% correct. -1 times -1 times -1. A negative times a negative is a positive, but times another negative is then a negative. So if we go and cube root both sides, my cube root cancels with my cube. And so x is equal to -1. Now it's really important in this case, when we cube root, it's not plus or minus. The reason it's not plus or minus is because if we go and consider multiplying 3 -1s versus multiplying 3 positive 1s, we've just established that a -1 times a -1 times a -1 is -1. But if I'm multiplying 3 positives, that stays positive. And +1 is definitely not the same as -1. So when you cube root, we don't use the plus minus. It's only if we square root. Okay, so can I get a thumbs up, thumbs down if we're happy with that? Good, Kaden, thank you. Thumbs up, thumbs down. Oh, you guys are doing so well tonight. Well done. Great, guys. You are so on it. I'm so proud of you. We just now need to get you to talk more. You got this. You've got to have faith in yourselves. You've got this. Alrighty. So let's have a look at one last example. Right. Those of you with the thumbs down, remember, either ask a question or remember that the lessons are recorded. So you definitely can go back and re-watch this to get some more practice. Okay. Right, so question 4, let's do this last one and then we can get going on the quiz. And then you can have a lovely night.
Quiz day.
All right, so 2x cubed plus 1 equals 55. Now again, if I had given you the equation without the cube, so 2x plus 1 equals 55, I know that you guys would automatically say, okay, cool, I'm going to subtract 1 on both sides. And that doesn't change here. Just because I've got a cube doesn't change how I do things. So I'm going to subtract 1 on both sides of my equation, which is going to leave me with 2x cubed is equal to 54. Right, the next thing I want to do is get rid of that coefficient. So I'm going to divide both sides by 2. And maybe in the chat, or if you're again feeling brave, if you'd like to maybe raise a hand, can someone tell me what 54 divided by 2 is? All right, Kaden, awesome. Sorry.
Well done, my people. Thank you, guys.
54 divided by 2 is 27. Now, again, if you are really comfortable with cube numbers and squared numbers, you can definitely just get it like this. Bear in mind, on your calculator, there is a cube root button and a square root button, so you can use it if you're not 100% sure. But from this point, we now need to say, okay, what 3 identical numbers, when I multiply together, give me 27? And so I saw sort of earlier on, once we've cube rooted both sides, we see that our answer is 3, because 3 times 3 times 3 is 27. Those are my 3 identical numbers that when I multiply together, give me the 27. Okay. Right, so exponents, really not too tricky at all. It's just a case of remembering all of your inverse operations, so all of your normal equation rules, and then just remembering what an exponent means and how we can deal with it.